Hi, I just wanted to welcome everyone to our online study session. And if you guys are online, we just wanted to let you know that there are some people in the room. If you're on campus, you can come to 126 and join us. And we also have some people online. But the first thing I want to do is I want to see if you can hear my voice. So if you can hear my voice, there's a button to raise your hand. Go ahead and hit that button for me. And Professor Ruher, can you show them the button to raise your hand? Can you circle it on the screen? The one that says raise your hand on the screen in the middle? Go to the middle of the screen. Yep. And then that first arrow on the left side up there, yeah, that's the raise your hand button. So if you guys could raise that hand for me. All right, good. So it sounds like everybody can hear me. I also wanted to show you guys online how to ask questions. There's a box on the bottom. That's where you can type any questions you have, or if you just want to talk to me and say if you can't hear me. So if you could just take a second and type hello into that box. And I see Roderick. Good. Wendy, all right. And all right. So it sounds like everybody can hear me. Professor Ruhe, do you want to say something to make sure they can hear you?
Yeah, well, hello, how are you doing? I'm Juan, and I hope everybody listens to me really well because I always speak a little bit loud, so I don't know if I'm too loud for you, so please tell us. And I need people here in the room to listen to me as well. So, do we have any complaint or are we okay? Okay. So this is the review for the final exam for intermediate algebra, and we're going to cover some questions. Here on the study sheet, we have 25 questions, but if you have different questions from those from the review, you can ask, and we can answer for you. We have no problem for that. And the first question that we have here is, write the equation of a line containing connecting the given points. The points are 8, -3 and -5, 4. So to find this kind of problem, the first thing we have to do is, by any chance do you know? Find the slope. Almost every time you have 2 points, you have to find the slope. And by any chance do you remember what is the formula for slope? y2 minus y1 over x2 minus x1. Perfect. Now, don't forget that here the points, the first point is normally called P1, and that's the reason we call it x1, y1. And the second point is going to have coordinates x2, y2. Well, I'm sorry if I'm messy with the handwriting, but it's my first time using this. Okay, so plugging in here, we have 4 minus -3. Those are y2 minus y1. Be careful with the double negative. Don't miss the negatives. That's a common mistake I see on my students. And on the bottom, we have x2 minus x1. So this is -5 minus 8. Now, as I told you, don't forget the double negatives. So this double negative means actually that we have a plus. So this is 4 plus 3. And simplifying, we get 7 over -13. So we have the slope of this of the 2 points of the line that contains the 2 points. Now we need to use a formula to find the line. How do we find the line? Point and slope form. So that is y minus y1 is equal to m times x minus x1. Now, for x1 and y1, you can pick any one of the original points. I'm going to use the first point, so that means x1 and y1. And don't forget that m is going to be the slope. So we're going to have y minus, we have -3. So again, be careful with the double negatives. And this is equal to 7 over -13 multiplied by x minus 8. So, well, normally we want the answer in the form y is equal to mx plus b. So we have to simplify this and leave the y by itself. So, first of all, negative and negative is positive. So we have negative 7 over 13 x minus 8, and then we have to distribute. We have here a distribution, negative 7 over 13. So we have y plus 3 is equal to negative 7 over 13. First multiplies to x, and then it multiplies to negative 8. So negative and negative is positive, and it's going to be 56 over 13. Remember that this number, the 8, can be treated as 8 over 1, so you don't get confused when you multiply. Now, we need to cancel this 3 here, so subtract 3 on both sides. I'm going to do it here. So we get that y, we cancel the 3's here, and we get negative 7 over 13x plus, now we have to combine these two fractions. Now, this 3 is actually 39 over 13. So you have to get the common denominator. So now we subtract 56 over 13 minus 39 over 13, and we get 56 minus 39, it is 17. So we get here 17 over 13. So this is the equation of the line that connects the 2 points. Questions so far? Similar questions about this? Now, some professors teach this in a different way. I'm going to erase, and some professors prefer using the formula y is equal to mx plus b, and plug the numbers, plug the x, the y, and the m, and find b. And at the end, you plug the b. So just in case, we can plug in here, negative 3 is equal to, the slope was, what was the slope? Negative 7 over 13. And you plug the x in this case is going to be 8 plus b. So now the goal is to find b, so we have to multiply here and then move to the other side. So negative 3 is equal to negative 56 over 13 plus b. We need to add both sides by 56 over 13. And here we cancel these two. And finally, we get the number here, which is 17 over 13. From the previous screen, you can find that value. So that is the y-intercept of the equation, and the final answer could be y is equal to negative 7 over 13x plus 17 over 13. So there are two ways to solve this. One of them is using the Spohn-Slope formula, or if you want, you can go straight to the y is equal to mx plus b form and plug in the numbers. Questions? Tell me. Oh, the 17 over 13. Okay, I did it on the previous screen. So to get the 17 over 13, we have negative 3 plus 17 over 13. Don't forget you need common denominator. So the common denominator here is going to be 13. So we get 13 here. So to get the common denominator, we need to, well, you can treat this as 3 over 1. So you're multiplying here by 13. So you have to multiply the 3 by 13. So you get negative 39 plus 17 over 13. When you combine these two numbers, negative 39 plus 17, you get, this was supposed to be 56. This is 56. And now negative 39 plus 56 is 17 over 13. Okay. Now it makes sense. Sorry about the mistake. Okay, and I did it in the previous screen, so probably you got it before. Okay? Okay, you're welcome. So now, question number 2. Find the equation of the line satisfying the conditions that the line is parallel to 3x plus 7y is equal to 3. So in this case, when a line is parallel to another, they have something in common. parallel lines means they have the same slope. So the first thing we have to do is find the slope of 3x plus 7y is equal to 3. So to find the slope here, we need to change 3x plus 7y is equal to 3 to the form y is equal to mx plus b. Yeah, as usual. Okay, so we have 3x plus 7y is equal to 3. We need first to subtract 3x and subtract 3x. And remember, the goal is to leave y by itself. So we cancel here and we get 7y is equal to 3 minus negative 3x. Now, we divide here by 7 because we need y by itself. Don't forget, divide every single term by 7. So you cancel the 7, and y is equal to 3 over 7 minus 3 over 7x. Now, we're looking for the slope. And the slope in this case is the number that is with the x. So negative 3 over 7 is going to be our slope. Now we know that the lines are parallel and we have a slope here. So the slope is going to be the same. So we have the information. M is equal to negative 3 over 7. And the point is negative 6,7. So again, we can use the point slope formula. And we can find the line. Y minus y1 is equal to m. M multiplies x minus x1. So replacing, we get y minus 7 is going to be equal to negative 3 over 7 times x minus negative 6. Be careful. Again, we have double negatives here, so they are really easy to get confused with. So we have here negative 3 over 7 factor of x plus 6. If you want, you can leave the answer like this, but some professors want the answer to be y in the form y is equal to mx plus b. So first, do the distribution. Negative 3 over 7x minus, here multiplying, don't forget that this 6 can be treated as 6 over 1, and you multiply, and you get 18 over 21. I'm going to simplify. Y minus 7 is equal to negative 3 over 7x minus 6 over 7. And finally, I have no space. I have to add 7 on both sides to get and combine these two numbers. I'm going to do it here. This is going to be y after canceling the 7s, and we get this is equal to negative 3 over 7x minus 6 over 7 plus 7. Now, don't forget, you have to combine these two. We need to get the common denominators. You can treat the 7 as 7 over 1. So common denominator between these two is 7. Don't forget, you multiply here by 7. You multiply here by 7. So we get y is equal to negative 3 over 7x minus 6 over 7 plus 49 over 7. Now we can combine these two last fractions, and here in the corner, y is equal to negative 3 over 7x plus 49 minus 6 is 43. So that is the final answer. So the main point here is, if the lines are parallel, the slopes are going to be the same. Questions so far? Alberto, do we have questions? Nope. Okay, so that was for parallel. On the next question, we're going to have perpendicular. Yeah, okay, so now for perpendicular, the main deal here is to remember that when you have the slope of a line, if the slope is m, don't forget the slope of the perpendicular line is going to be the opposite reciprocal. So in this case, first, we need to find the slope of negative 3x plus 4y is equal to negative 23. So finding the slope here, we need to add 3x on both sides. So we cancel, and we get 4y is equal to 3x minus 23. And divide by 4. Divide every single number by 4. So we cancel the 4's. We get y is equal to 3 over 4x minus 23 over 4. Now, the slope here is 3 over 4. I like to call it m1. And we're looking for the new slope, or the slope for the new line, and this number has to be the opposite reciprocal of 3 over 4. When we mean opposite, don't forget to change the sign. 3 over 4 is positive. That means change to negative. And the reciprocal means flip the fraction. We have 3 over 4. When you flip, you get 4 over 3. So that's going to be the slope of the new line, the line that is perpendicular to the original one. So here we have the information. M is equal to negative 4 over 3. And we have the point negative 3, 8. So again, using y minus y1 is equal to m x minus x1, we have y minus 8 is equal to negative 4 over 3 x minus negative 3. We need to leave this answer in the form y is equal to something. Y is equal to mx plus b. So we have y minus 8 is equal to negative 4 over 3. Don't forget the double negative. That's the first thing you have to simplify. So we have negative and negative becomes positive. So we get x plus 3. The next step is distribution. So this is negative 4 over 3x plus, well, treat this as a 1. So when you multiply, you get, well, this is going to be actually a minus 12 over 3, which becomes a 4. Y minus 8 is equal to negative 4 over 3x minus 4. And finally, add 8 on both sides. So we're going to get the final answer. So y is equal to negative 4 over 3 plus 4. Oh, I forgot the x. Negative 4 over 3x plus 4. What? Okay, tell me. Yeah, 2 questions. Okay, so in this case, normally to find the equation of a line, there are 2 options. One of them is y minus y1 is equal to m times x minus x1. This is point slope. If you want to find the equation of a line, you can use this formula. But remember, you have the slope, and you have to plug one of the points into x1 or y1. Now, there is another formula that you can use, and it is y is equal to mx plus b. This is the point-intercept form. And you can use it as well in any time, as long as you have a point, and you plug the point into the xy, and you plug m. Don't forget, you have to find b, and at the end plug b into the formula. Find b and plug into formula. Yeah, the point-intercept form. People always like to forget to plug the b after they find the answer. You have a question? Yeah, it's really good to know. I always prefer using the point and slope form because when you plug it in, you plug the numbers in, you're gonna get the answer in a straightforward way. You have to do a couple of calculations and you get the formula. You get the equation you're looking for. So more questions? Oh yeah, yeah. Some professors actually like to leave the answer as y minus the number is equal to m times, and that's an equation. Some people believe that that is enough. Yeah, that's a valid equation. Just plugging in that, that's all. More questions? Okay, so we go for question number 4. Okay, we have here, decide whether the relationship is a function. The question here is how do we know that this is a function or not? Only when we have points. So the thing here is, are you repeating numbers on the first coordinate? Or that means every point is in the form x, y. Are we repeating values for x? Yes. Here the first two points are repeating the -8 and the -8. So we have a repetition of the numbers. Immediately we can say that this is not a function. Now, if I have something like this, -8, 2, 8, 8, 1, -3, 3, -3, and finally 7, -3. Is this a function? Yes, this is a function. We're not repeating anything on the first coordinates. It is not a function because we're repeating the x coordinate, and well, even though we're repeating, we have different values for the y coordinate. No, well, if you repeat the x, you have to repeat the y. It's like you're doing like something twice. Yeah, it's a relation. Yes, a relation is when for every x, you have a different value of y. Exactly 1, yes. Yeah, for every x on the domain. Yeah, and we're going to go there for domains in a second, and that scares so many people. So this one, the one that we have at the bottom, it is a function. We're not repeating any numbers on the y coordinate. Now, on the x coordinate, I mean. Now, we're repeating values here on the y coordinates, but that's not a problem here. We can repeat as many numbers on the y coordinate as we want. So yeah, so it is a function. Questions? Nope? Okay, let's move to question number 5. Solve the problem. Find f of 1 over 4 if f of x is equal to 5x squared plus 8x plus 6. So when you have a function and you have a number inside the parentheses that relates the function, the only thing you have to do here is replace every x by the number inside the parentheses. You're going to say something? Oh yeah, f is not a number, and 1 over 4 is not multiplying f. Yeah, 1 over 4 actually replaces x, or it's, yeah, 1 over 4 is replacing the x. Okay, so what we have to do here is replace every single x by 1 over 4. So f of 1 over 4 is equal to 5, 1 over 4, replacing the x, never forget your square, plus 8 times 1 over 4 plus 6. So now it's only performing operations. This is, here you have to simplify using the order of operations. So exponents go first, and we have to say that this is 5 times 1 over 16. Remember that 1 over 4 times 1 over 4, 1 over 4 squared is equal to 1 over 4 times 1 over 4. and then we have 8 times 1 over 4 plus 6. So now, in order of operations, we have multiplication that goes next. So this is 5 over 16 plus 8 over 4 plus 6. And now we have to combine all these fractions. So we have here, well, the common denominator is going to be 16. Well, yeah. So I'm going to say that we have to multiply this fraction by 4 to get the common denominator 16. And 6 can be treated as 6 over 1. And we multiply by 16 on top and bottom. So we get 5 over 16 plus 32 over 16 plus 6 times 16 is 96. 96 over 16. So now we combine and we get 32 and 96 is 128. So 128 plus 5, it is 133 over 16 after combining 5 plus 32 plus 96. If you want, you can simplify this answer and leave it in mixed fraction, but I don't think it's needed. But if you want, don't forget to divide 133 into 16. How many times the 1 is 16 into 133? That's 8 times? Yes, that is 8 times. So this is 8. We have, well, actually, it's better to do it by hand. So 133 into 16. 16 is 8 times. 8 times 16 is 128, and we subtract, and the remainder is 5. So we get 8, the quotient or result goes here, and the 5, which is the remainder, is going to be the numerator of the new fraction. And that would be a final answer. Questions about this? Okay, so it's time to go for the next question. Solve the system by substitution and then show the graph below. So we have first to solve by substitution. By substitution, we need to pick one of the equations, and in one of the equations solve for one of the variables. That depends how the problem is here. In this case, probably, well, it's easy in any case, in any equation, and to pick any single variable. So I'm going to pick on the first equation. Well, this is going to be the first equation. And this is going to be the second equation. I'm going to pick on the first one. I'm going to solve for x. So solving for x, x minus y is equal to 2. I'm going to add y, and I'm going to add y. Cancel here, so x is equal to 2 plus y. So now, the main thing here is, when you have one variable by itself in one of the equations, you go immediately to the other equation, in this case the second one, and replace the value that you found with the result. So instead of x, I have x plus y is equal to 8. I'm going to replace this x by the 2 plus y I got from the first equation. So I'm going to say 2 plus y is equal to 8. I'm going to put the 2 plus y in parentheses, meaning that this x is being replaced. So now we can combine like terms, and we get 2 plus 2y is equal to 8. Now we have to solve for y. So subtract 2 on both sides. Cancel. So we have 2y is equal to 6. And dividing by 2 and dividing by 2, we get y is equal to 3. Now, some people stop here. Remember, you're looking for a point. You're looking for both numbers, x and y represent a point on the plane. So after you find y, you have to look for x. So you have to use either one of the original equations, number 1 or 2, or sometimes if you have something simpler like this one, x is equal to 2 plus y, and you can plug in. So x is equal to 2 plus 3. In this case, I'm replacing y by 3. So x is equal to 5. So the answer is going to be the point 5, 3. Now, this 5, 3 is a point on the plane. I'm going to try to get it here. This is 5 and this is 3 here. So the answer should be approximately here. Now, what is happening is we have two lines. One is x minus y is equal to 2. Or actually, we have the line. This line is x minus 2 is equal to y. Or looks better if we say y is equal to x minus 2. So this is a line with a slope 1. Slope is the number with the x. And negative 2 is the y-intercept. Well, 0, negative 2. So we have negative 2 here. And the slope is 1. So let me get this. So the line should be something like this. This graph is x minus y is equal to 2, or you can write it down as y is equal to x minus 2. Now, the other equation, I'm going to write it down here. The second equation, which is x plus y is equal to 8, can be written, after subtracting x, as y minus is equal to 8 minus x. So this line has a slope negative 1. We can write down here a 1. And the y-intercept is going to be 8. So we have the y-intercept here. And the slope is negative 1. So we move one space down and one space to the right. We connect the points. And we see that the graphs, oh, well, it's supposed to be a straight line. Okay, that's good. Okay, so the lines are supposed to meet at here the point 5, 3, as we found before. So you can either graph or you can use substitution to solve this kind of problems. And later we're going to see elimination method, which works in a similar way for graphing and everything, but you have to set a couple of steps different. Questions here? Comments? Suggestions? Okay, we have to check the answer by substituting the values into both equations, not only one. Yeah, so here in any case, if you want to check your answer, check on both equations. So on the first equation, you can say this is 5 minus 3 is equal to 2, which is true. And on the second equation, you can say 5 plus 3, after replacing x and y, you get 8. So those answers, the answer 5, 3 is correct. But please try to do it on both. Okay, so we go for question number 7. Solve the system by substitution. Now, this system has something really, really nice. And it is that one of the equations is already solved for one of the variables. You can see here the first equation is already solved for y. So y is equal to 7 over 6x. We can replace the y on the second equation and we can say this, 7x minus 6 times 7 over 6x. And that is equal to 0. Now, we have to solve here. And first, simplifying 6 times 7 over 6. We can say that this is 6 over 1. And we can simplify fractions. We can say 6 and 6. They cancel. So we get 7x minus 7x is equal to 0. And simplifying beyond that, 7x minus 7x, they actually cancel. When things cancel and there is nothing else, when canceling by subtraction, we get 0 is equal to 0. And when we get 0 is equal to 0, here what we have is an identity. That means that the system is dependent. That's one of the few meanings that this problem has. The system is dependent, or at the same time, you can say that when you graph the lines, they overlap each other. They are equivalent equations, yes. And at the same time, what else can we say about this? Well, and we can say that here we have an infinite number of solutions. Now, the answer is not infinity, because infinity could be actually a big number. Here, remember, we have a different amount of solutions. We have solutions x, y, and those solutions x, y are those that satisfy the equations. So we can have an answer 0, 0, and another answer could be 1, 7 over 6. Every point on the line. They're equivalent equations. Okay, I can say this. I can use the second equation here, and I'm going to solve for y. So as solving it for y, we have 7x minus 6y is equal to 0. Solving for y, I'm going to add 6y on both sides. So I cancel here, and I have 7x is equal to 6y. Now, I have to divide by 6. Remember, we're solving for y. So we cancel the 6, and we get 7x over 6 is equal to y. And this equation is actually equal to equation number 1. So that's the reason we can say that both equations are equivalent. You make a small change or a couple of changes, and you get the other equation. Yeah, that's common. Some students actually, when they cancel, they forget that sometimes something's left. Like subtracting something, you get a 0, or like dividing, you get a 1. And people tend to forget that there is a 1 or there is a 0, and they miss half of the information there. Okay, questions so far? Nope? Okay, let's go for number 8, which is solve the system by addition. This is addition, or some people call it elimination. For this kind of problem, what we need to do is we need to multiply both equations by suitable numbers. And the idea is to get the same coefficient for one of the variables with different sign. So we can add or combine the equations so one of the variables gets canceled or gets eliminated. In this case, the best thing to do is probably multiply by -2, the second equation. So if we multiply here the second equation by -2, remember, multiply every single term. So we have the first equation remains as it is, and the second equation is going to become 6x plus 4y is equal to 24. So the idea is we get the coefficients of the y the same with different signs. So we can combine every single column and get an answer. -7x plus 6x is going to be -x. Now, -4y plus 4y, they vanish, they cancel each other, so we can erase them. And finally, -24 plus 24, that gives us a 0. So well, we need x by itself, so we have to multiply or divide by -1 on both sides, and we get x is equal to 0. That's the first answer. Now, we need y. Don't forget we need x and y. So to find y, we plug the 0 into one of the original equations. I'm going to use the first equation. So I'm going to say -7 times 0 minus 4y is equal to -24. So -7 times 0 is 0. 0 minus 4y is equal to -24. 0 minus 4y is actually -4y, and this is equal to -24. And we divide by -4 on both sides, and we get y is equal to 6. So the solution for this problem is 0,6. And now we have to check if both answers fit on the equations. So plugging into the first equation, -7 times 0 minus 4 times 6 should be equal to -24. -7 times 0 is 0, and we have 4 times 6 is 24. So on the first equation, 0 minus 24, we get -24, and the numbers match. On the second equation, we plug in again -3 times 0 minus 2 times 6. This should be equal to -12. So we have 0 minus 12 is equal to -12, and again, -12 is equal to -12. So the answer is correct. Yeah, so what you mean is if you have -3x minus 2y is equal to -12, the idea is multiply both sides of the equation by -2, like this, and multiply this other side of the equation by -2. I would prefer actually saying you should multiply every single term by -2. So I would multiply here by -2, and I would multiply the -2y with another -2. Okay, so here what happens is we're multiplying one of the equations by a suitable number. In this case, we're using -2 to get a number that can be combined with the 4y. Let me find the eraser here. I need to erase a couple of things. Okay. So we're multiplying the -3x minus 2y is equal to -12. We're multiplying that by -2. And when we multiply by -2, we see that the y's are going to have the same coefficient with different sign. So by the elimination or addition method, we're going to combine both equations. We have -7x and 6x. We combine like if they are like terms. They are actually like terms. So -7x plus 6x is going to be -x. -4y plus 4y. They cancel because they are the same expression with different signs. And on the other side of the equation, we have -24 plus 24, which give us 0. And after that, why is it -2? Yeah, it has, in this case, we're actually saying multiply the first equation by one of the numbers on the second equation and multiply the second equation by one of the coefficients on the first equation. Yes. I know that's kind of confusing, but if you multiply by those numbers, make sure that one of them is going to give you a different sign than the other one. So in this case, multiplying by 2 on the second equation give us 4, the 4 that we're looking from the first equation. Another question? I'm going to erase, and probably we can get something else. We can multiply the first equation by 3. I can multiply the first equation by 3. And I can multiply the second equation by -7. And in that case, we can simplify the x's. if you multiply the first equation by 3, you get negative 21x minus 12y is equal to 72. And the second equation is going to be 21x plus 14y, and that's equal to 84. So on the x's, the coefficients of the x of both x's are going to be the same with different signs. So what I did is multiplying the first equation by the coefficient of x on the second equation, multiplying the second equation by the coefficient on the first equation. And I'm trying to match the signs, so one of them is going to be negative and the other one is going to be positive. From here, we get negative 21x plus 21x, that's 0. And here we get 2y is equal to 6. No, that number is too big. Oh, this is negative 72. So this is going to be 12. When we divide, we get y is equal to 6 as we got it before. And from here, x is going to be equal to 0, and as we did it before. Oh, yeah. Yeah, I'm multiplying here by negative 7. Okay. More questions here? No? Okay, let's go to question number 9. Find the domain of the rational function. H of x is equal to 3 over x squared plus 12x plus 35. So this is a rational function. I'm going to say that h of x is equal to p of x over q of x. And the main deal here is, in every single fraction, we're not allowed to have the denominator equal to 0. Remember, division by 0 is not allowed. It is something that is undefined. So here what we have to solve is the denominator, the equation, the denominator equal to 0. In this case, the denominator is going to be x squared plus 12x plus 35. And we have to solve this equation equal to 0. Now, this is a quadratic equation. In the case of quadratic equations, there are two main ways to solve them. One of them is by factoring. The other way is by using the quadratic formula. In this case, it is easy to factor because, well, it is x squared, and we can find two numbers that multiply are 35 and added are 12. So we can say that this is x plus 7 and x plus 5. So if you FOIL, if you multiply, you get x squared, x times x, then x multiplies the 5. I'm going to do it here on the side. This is x squared plus 5x, then 7 times x. And then we multiply 7 and 5, that is 35. So we get x squared plus 12x plus 35. So after we factor, we can split and solve. So take every single factor and make it equal to 0. And solve both of the equations. Subtract 7 on both sides on the first equation. So x is equal to negative 7. And subtract 5. X is equal to negative 5. So those two are the values that are not going to be on the domain. Yeah, they are the non-answers, yes. So in this case, we can have some professors allow this. X cannot be equal to negative 7, negative 5, but some other professors prefer the interval form notation, which is from negative infinity up to negative 7. Remember, 7 is not included, so we have to stop there and start a new interval at negative 7 that goes up to negative 5. And a new interval from negative 5 up to infinity. When we have negative 5 union negative 5, that means that we're not including the negative 5, and the same happens here between -7 union -7. Do we have questions? Okay, simplify the complex fraction. So to simplify this fraction, it's better to multiply the numerator and the denominator by a common denominator. So here we have, well, I'm going to treat this as 4 over 1. And we have 4 over 1 plus 2 over x. This addition is going to be over x over 4 plus 1 over 8. So we have denominators 1, x, 8, and 4. So the common denominator in this case is going to be 4x. I'm going to multiply the numerator, or the fractions that are on the numerator, by 8x. Oops, I was missing a number. So by 8x, and I'm going to multiply numbers on the bottom by 8x. So this is going to allow us to cancel denominators, so this is going to be easier. Multiplying 8x for every single fraction, we have 4 times 8x is equal to 32x, plus on the second fraction, we can say this is 8x over 1 and this is 8x over 1. We have 16x over x. We're going to simplify on the next step. This is now 8x over 4 multiplying 8x over 1 times x over 4. Oh, this is x squared. This is 8x squared. Plus multiplying 8x times 1 over 8, we get 8x over 8. Now, simplifying fractions, we get 32x plus 16 over, and simplifying fractions on the denominator, we get x squared plus x. Now, oh yeah, this is a 2. Thank you. So on the denominator, we get 2x squared plus x. Now, we can simplify further, and we can factor on top. On the numerator, we get 8 factor of 2x plus, actually we can use 16. 16 as a common factor. 16 is a common factor, 16 times 2x plus 1. On the denominator, x is a common factor. So x factor of 2x plus 1. Now, we see that we have a 2x plus 1 on top and 2x plus 1 on the bottom. So we can simplify and we get 16 over x. So here you have to simplify a couple of times, but the main point is try to clear all denominators first. So operations are going to be easier. Probably simplifying a fraction or solving an equation. Try to clear denominators, and problems are going to be absolutely easier. So questions for this part? Okay, so I'm going to pass this to Professor Meltzer, and she's going to continue with you answering more questions. And have a nice day and enjoy the rest of the evening.
Hi everyone, I'm Professor Meltzer. I just want to make sure that you can hear me okay. So if you could just raise your hand, press the raise your hand button. I'm pretty loud and high pitched, so just tell me if I'm too loud. Okay, so to recap what we did up here is to simplify, first of all, we want to get rid of what I call these mini fractions that we have going on. So you can see here we got this 2 over x, we have an x over 4, we have a 1 over 8. The final answer, the very most, should just have one fraction bar at the end. So to eliminate these mini fractions, we need to get rid of the denominators, essentially. So to get rid of the denominators, they're all different. We have an x, we have a 4, and we have an 8. So the way we can do that in one clean swipe is we find the LCD. So the LCD, and don't let that L mislead you, by the way. L is the smallest number that they all divide into, so a lot of times that ends up actually being the biggest number. What do I mean by that? Well, let's take a look at our current denominators. We have a 1 here. A 1 goes into anything, so that's not a worry. X, that's the only letter, so that's going to be part of our common denominator. And then we have a 4 and we have an 8. So what's the smallest number that 4 and 8 divide into? It's actually going to be 8. So that's why a lot of times I tell my students, kind of ignore this L in a way, because it actually check the biggest number there, and if that doesn't work, it's a bigger number that they all divide into. And that, so 4 and 8 divide into 8, so 8x is our least common denominator, and that's going to be our key here into getting rid of these mini fractions so we can simplify our answer. Now what's really neat about this is that there are a couple different ways you could have done that. If you use any common denominator, you could have gotten rid of those fractions. For example, what else do 4 and 8 divide into besides 8? 16. So if you chose 16x, that would have worked. 4 and 8, when you multiply them together, go into 32, 32x, that would have worked. So any number that those denominators divide into, and then you also include the letter as well, because that's on the denominator as well, any common denominator is going to work here. It's just the quickest, easiest way is to find the least common denominator, and so the smallest number that 4 and 8 go into is 8. So you have 8, and you have your x. Okay, now we're going to times every single term in the numerator and denominator by that least common denominator, which is 8x. And to make it easier to see, I'm going to make this a fraction to start with as well. So I can put it over 1 to make it a fraction, that way I don't change the value of it. So that's what Professor Rouge did up here. Now when you take that 8x over 1, remember you got two terms on the top and the bottom, so you're distributing this to both terms on the top and bottom. So when you distribute, make sure that you keep your numerators together and your denominators together, because when you're multiplying fractions, you multiply across. That's what's nice about multiplication as opposed to addition or subtraction. You don't have to have the same bottom right away, you just multiply straight across. So when I multiply the first, I have 4 times 8x, which is how we got the 32x. He didn't write the denominator here because look at what's on the bottom. You got 1 times 1, so it's over 1. Do I really need to write over 1? No, because 32x divided by 1 is 32x. Now I go over here. The 2 matches with the other numerator, which is 8x. 2 times 8x gives you the 16x. On the bottom, you have x times that 1 that we put in the denominator there. X times 1 is how we got x on the bottom. So that takes care of the 2 on the top. Now on the bottom, we're going to do the same process. 8x times x, matching those numerators up again, gives you 8x squared. Remember, x times x, when you multiply by the same letter, you add the exponents. That's a 1 and a 1 for a 2. On the bottom, you have a 4 times 1 for 4. Now the last term here on the bottom, you have 1 matching up with the numerator of 8x. So 1 times 8x is how we got the 8x. On the bottom, 8 times 1 gives us that 8. And here's why this works, because stuff starts canceling to 1. When you divide by the same letter, divide by the same number, with the exception of 0 over itself, of course, it goes to 1. So right here, x divided by itself cancels to 1, so you just have the 16. So you have the 32x that he brought down plus that canceled to 16. Over here, 8 divided by 4, well, that goes to 2, and then he just brought down the x squared. Plus, here's some more cancellation, because you got 8 divided by 8 cancels to 1x over 1, which is 1x. So again, this went to 2 over 1, and that's how we got the 2 here. So now that the many fractions are gone, the last part, I know it's a really long problem, after that is we say, okay, can we factor? And we can factor by using the GCF method. Why do we want to factor? Well, a lot of people say, why can't I just cancel out? I have an x here and an x here. Can I just slash them? Remember, when you have more than one term like this, you are not allowed to invade across addition lines. I can't just cancel with addition and subtraction. I can cancel, though, if it's multiplication. And that's why factoring is awesome, because what factoring does is it creates a multiplication format for us. So on the top, when I factor this, so I can create a multiplication, so that way if there's a match on the top and bottom, I can cancel it out. When I factor this, I say, what's the biggest number that goes into 16 and 32? Because there are a lot of numbers that go into both those. And the biggest number is actually 16. That's going to be our greatest common factor. And so when I use the greatest common factor method, I use it twice. I list it out front, the 16, and then to get these new terms in the parentheses, you divide each of the original terms by that 16 that you divided out front. So when you have 32x divided by 16, you're left with 2x. Plus 16 divided by itself is how we got the 1. Down here, GCF method again, because these two terms have something in common. Now number-wise, just a 1, but letter-wise, variable-wise, x. So when they have the same letter, you choose the smaller powered one for GCF, x to the first. So now I list it again out front, and then to get the new terms in parentheses, we divided each of them by x. So we bring down the 2, x squared divided by x is x, because remember when you divide by the same letter, you subtract the exponents. We can assume that's a 1 if it exists, but no exponent is written there. 2 minus 1 for a 1. You don't need to write a 1 if it's x to the first, x. Plus x divided by itself is 1, just like 16 over 16 was 1. So now that we've factored it, we've created a match, and now we're allowed to cancel out our match because it's multiplication. So 2x plus 1, 2x plus 1 cancels, and you're left with 16 on the top divided by x on the bottom. How are we doing, guys? I know that's one of the harder problems. It's from chapter 4, by the way. It's somewhere around 5.4. Question? So you're saying you would write the 16 like this, right? Out here, and your x out here to show it? Yeah. Yeah, no, the only reason I wrote that, that's not equivalent. You're correct. It's just to show, because you're right, you go from this step here down to this factored form. I have the factored form if you look at the very bottom there, and I was just showing the students how he got 2x plus 1. Are there any other questions?
Hey, if you guys are listening online, so what just happened was there's a step in the problem in which Professor Meltzer was clarifying Professor Ruhe's steps. So she took out a factor of 16 from that 32x plus 16. And there's another professor in the room who's just clarifying that technically that's not mathematically equivalent. We can't just divide everything by 16. The GCF has to be written out front. And so he just wanted to make that point. And I know you guys couldn't hear online, so I just wanted to clarify it for you. This will also be on the recording, so that when they hear in the recording, it'll be clarified. We okay? Does that sound correct?
Sure.
Thank you.
Okay, so we have two fractions. It says perform the indicated operation and express in lowest terms. Now, in order to subtract fractions, we need to have the same what? Denominator. Good. So we need the same denominator, and you can see we do have that same denominator. Indicated operation is subtraction. So on the denominator, we have x squared minus 2x minus 24. Since they both already have the same denominator, I'm allowed to subtract. But be careful here, because when I'm subtracting, that means opposite sign. So when I'm subtracting, I need to make sure that when I combine this into one big old happy fraction here, that I subtract both of these terms. I distribute that minus to both of them once it's combined here. So I still have the 3x plus 26. And then this positive x is now, because of this minus sign, going to become negative x. And this positive 18, because we're subtracting, is going to become negative 18. So that's probably one of the easiest mistakes to make. So again, be on the lookout. Everything after that minus sign, you need to apply the minus sign too. Minus means opposite. All right, so we can collect our like terms on the top for starters. So we see here we got a 3x minus, that's like saying minus 1x. So that leaves us with 2x. So 3x minus the x gave us the 2x. And we're left with 26 minus the 18. So we get a positive 8. And then just like with the last one, we always check, can we simplify? Can we go further? So the way we do that, again, we can't just go across lines. I can't just slash these x's, or 8 goes into 24. I can't slash these because I can't invade addition or subtraction lines. So we're going to factor the numerator and denominator, and that way we're creating that multiplication format again. And then if we have a match, we can cancel those matches out to 1 on the top and bottom, so that way we're left with less stuff. So on the top, we can use the GCF method yet again. What's our GCF of 2x and 8? What goes into 2x and 8 is 2. And when I divide the 2x by 2, I'll write it over on the side margin. So if you have a professor, we have a professor in here, what his point was in the last part was write it off to the side, because if you write divided by 2 here, technically you're making something non-equivalent. So if we do it off to the side, this is just scratch work off to the side here. To get our new terms, we use the GCF again by dividing by 2. And that'll give us the new terms in the parentheses. So when I divide each of those by 2, we're left with 1x plus 8 divided by 2 for 4. Now, Professor, would you accept this on a test if they just did this off to the side as scratch work, since it's not saying it's equivalent? Is that all right on a test if a student does that? For just scratch work off to the side showing, because they're not saying equals? So if it's on the side margin, that would be counted as full credit in your class? Okay, just so it's not over here where the equals is, correct? So you're not saying equivalent. Okay. And now down here, we do have a trinomial. However, what's nice about this trinomial is the leading coefficient is 1. Yay! We can assume that's a 1x squared. Why say yay? Whenever the leading coefficient of a trinomial is 1, we can try factoring it without having to use a method. So we do not have to use trial and error or Colombian method or AC method. We can think it out logically. If you want to use one of those methods, it'll still work, but you'll just make it longer than it needs to be. So we get 2 blank parentheses ready to go, because we're going to end up with a binomial times a binomial. For the signs, you always drop down the first visible sign, which is a minus. And then to get the other sign, you multiply the 2 visible signs together. A negative times a negative, of course, is a positive. Or the other way that I've learned it is once your terms are in descending order, the last sign's a minus. Minus means one sign of each. So either way that you learned it, that's your sign rule. Now there's only one possibility of multiples that gives you x squared. And that's 1x times 1x, or x times x. So the multiples that work with the first term go in the first spots. So x times x, since that gives you x squared, go in the first spots. Now the goal always with trinomials, when you're factoring them, is the middle term, right here. That's our goal. So I look at the last term now, 24. Multiples of 24 could be 8 and 3, 2 and 12, yep, 6 and 4, good, 24 and 1. So you could think these or write these out, whatever's easier for you. And keeping in mind those signs, we're adding and we're subtracting. Which of these multiples of 24, when you add and subtract, will give you that middle coefficient of -2? 6 and 4, excellent. And it's very important which you put with which sign. So if I want a -2, that's my middle coefficient, I want to subtract which one, the 6 or the 4? Very good. Subtract the 6 and add the 4. Perfect. And that gives you -2. Again, if you're going, why didn't you do the 1 times 24? You could have, but I didn't have to. I don't have to use Colombian method or AC method because the leading coefficient was what number again? 1. So as soon as you see a 1 in front of that x squared when you're factoring that trinomial, yay, it's going to be a shorter, quicker problem. We can immediately factor that or try to factor that. Now, because we factored that, we have some factors that are in common on the top and bottom that cancel to 1. So our match clearly is x plus 4. So that cancels with the bottom to 1. So we're left with 2 in the numerator all over x minus 6 in the denominator. And there's your final simplified answer. Again, another tricky one. A lot of these Chapter 5 questions are tougher. Any questions, concerns? If I'm going too fast at any time, just say slow down. Okay, Okay, any questions on how I got any of these whatsoever? Feel free to ask up, guys. Was everybody able to copy it down okay before I go on to the next slide? Okay. Here we go again with another fraction. Now, with all these fractions, these rational equations, so we want to solve it. Now, we can't exactly solve for x right away if it's in the denominator. We need to somehow figure out a way to bring that up to the top, to the numerator, so we can actually solve for it. Now, what's going to be easiest, there's a couple different ways you can do this, but most students prefer to get rid of the fractions. They don't like fractions. So the way we do that, just like a couple slides ago, is the magic is with the LCD. And even if you were going to add and subtract fractions together, you need to find the LCD anyway. So I'm going to start everything off as a fraction. So if I want to make 1 a fraction, I'm going to put it over 1. So ironically, even though we want to get rid of the fractions, we're going to start them all as fractions. That way they're on equal playing field here. And I want to know, well, 1 goes into anything. But let's look at the other denominators, 2x and 4. So what do 2x and 4 divide into? Well, we know x is going to be involved. We have to include a letter if we see it. What about 2 and 4? What number do they divide into? We could use 8. We could definitely use 8. We could use 16. Those are all common denominators. What's the smallest number that 2 and 4 go into? Something very good, 4. So 4x would be your least common denominator. But you could always, again, use a common denominator. Like somebody here brought up a really good point. They said 8x. Because you could times all the denominators together, 1 times 2x times 4, you get 8x, that would also work. But the smallest number is 4, so we're going to go with that. And again, I'm going to put it over 1. So I'm going to start everything as a fraction, but we're going to end up getting rid of the fractions. How? Well, here's the trick. We multiply just like that complex fraction that we worked with, I think it was question 10. We're going to multiply every single term by this LCD over 1, by 4x over 1. So here we go. So I have 1, which I'm going to put over 1 so we can see better what's on the top and what's on the bottom. And immediately after it, I write times 4x over 1. And then I write the next term. The next term is negative 3 over 2x. And immediately after that, times 4x over 1. Bring down your equal sign. The last term on the right side here, 7 over 4. After that, 4x over 1. So let me pause, give everybody a chance to catch up, see if you have questions. Any questions on how I got the LCD? And again, please note, every single term on both sides is being multiplied. Multiplication and division you sweep through and you have to do to every single term on both sides.
I have one quick question.
Sure.
Can you talk a little bit about why the x is necessary?
Sure. Whenever you're finding the LCD with x's, if you ever see an x on the bottom, you have to include that as part of the denominator. If there were an x squared as well, then you would put the biggest powered x as least common denominator. I know, again, it's confusing because you see that L for least, but you end up choosing the bigger one. So whenever you have letters involved, you have to incorporate the letter as well. So when you have an x on the bottom, why the x is there essentially is I want to get rid of this x that's on the bottom. I want to get rid of the denominator so that way I don't have any fractions to work with. That way it's a nice, easy problem. I'm going to bring the x up to the top so I can actually solve for it. So the way we do that is we include that in the common denominator that we multiply by, and that's going to always bring it up to the top. So whenever you're simplifying by multiplying by a least common denominator, and whenever you have an x on the bottom, always include that as part of your LCD. Now if that x had not been on the bottom, if there was just an x on the top, then x would not been part of the least common denominator. So if just 2 and 4 were there, then your LCD just would have been 4. But whenever you see that x on the bottom, it needs to be part of your LCD. If there were an x squared, as I was starting to say before, then you would have an x squared there. You put the biggest, if you have matching letters, you put the biggest powered one. If there's an x cubed on the bottom, you'd have x cubed as part of your LCD. If there was a y there, then you'd have both x and y. When I say there, I mean in the denominator. So whatever letters are in the denominator, you need to be accounted for, just like the numbers are. and as the least common denominator. And we're going to see in a second why we need that x, how it's going to get rid of it in essence, bring it up to the top, I should say. It's going to pull it out from that denominator right here where it's causing the problem, and it's going to bring it up to the top. Very good question. Any other questions, guys? Okay, so when we do this, why it helps us cancel out these denominators is because when we multiply, and only with multiplying, are we allowed to slash on the diagonals. If anything besides 1 divides into the diagonals, we're allowed to slash into the diagonals. Again, only with multiplication. And so what's going to happen in a minute here is that all these denominators should go to 1 if you've chosen a correct common denominator. So here on the top, we have 1 times 4x, which is 4x. And on the bottom, 1 times 1, so over 1. Do I really need to write over 1 though? No. Now over here, here's the fun part. We got an x on the top, x on the bottom. X over x cancels to 1, so we can slash these x's. Yay. And now it's up to you if you want to slash. I like to slash with the multiplication, so what I would do is I would say 4 and the 2 on the bottom are both divisible by 2. So your 2, when you divide it by 2, becomes a 1. And when you divide this 4 by that 2 that was on the bottom, becomes a 2. And now look, we got 1s on the bottom. Yay! So we can get rid of our bottom, so we get rid of the fraction. So we're left with negative 3 times 2 now for negative 6. And since we have 1 times 1 on the bottom, we have a 1 on the bottom. We don't need to write over 1. Now if you don't like that, if you're going, oh, I don't like that, then just write off to the side if you don't want to slash what we had. What we originally had was 3 times 4x. So we originally had, for example, 12x. I'll do the scratch up here. Over on the bottom, we had 12x, or thank you, 2x, thank you, times 1. We had 2x. So if you don't want to slash, you can just multiply across what we had if you're going, I don't like that slashing thing she's doing. And then what happens is x over x cancels to 1, and 12 divided by 2 gives you that 6. So either way, you're going to get the right answer. So it's up to you if you want to just multiply across and then divide out what needs to be divided out, or you can do this fun little slashing technique that I'm doing. Equals. Now over here, if you multiply across 7 times 4x, you would get 28x over 4 times 1, so you get over 4. So when you take 28x over 4, you end up with 7x. Or you can do the fun little slashing technique, because 4 goes into itself one time. When you do the slashing technique, that's when the denominators become 1s, as I was talking about before. So you don't need to write that 1 on the bottom. So we're left with 7 times 1x, which gives you that 7x as well. So either way works. Now, look how much nicer this problem is than what we started with. Yay! So it's much more reasonable to work with. We can solve it for x. Now, yes, you're probably used to moving your letters, your variables, to the left. I'm proposing we move the letters to the right because it's going to be a little bit quicker, because you already got your number without a letter on the left side. You got a positive variable on the right. So I'm going to be a little rebellious here, and I'm going to move my variables to the right side. But you could do the opposite, and that works as well. So if you move your letters to the right, which x do I need to move? The 4x. Very good. It's currently being added because it's positive 4x. We can assume it's being added. So to undo it, we subtract. And notice how different subtraction is as well as addition. Addition and subtraction are very different than multiplication, because we should just subtract once from each side. Multiplication we did to every term, but subtraction we just subtract once from each side. So we're left with, because that cancels to 0, so we're left with negative 6 equals 7x minus 4x. We're left with 3x's. Finally, last step, yay, we divide over the 3. Very good. So that way we're left with 1x. So x equals negative 6 divided by positive 3, negative 2. And what's really cool is you can even check your answer, especially if you had a multiple choice final exam here, and see what works, because when you plug it in, it should give you a true statement if you've done it correctly. If you plug this x equals negative 2 into this x here, the very original problem, it should give you a true statement. If you get a false statement, something's wrong. Either your checking part of it's wrong or your answer is wrong, one of the two. Any questions on that one? Yeah, there's a professor question in here. The professor that's in the room was pointing out that you should check this answer whenever you're multiplying any equation by a variable. If you were to graph this on a graphing calculator or to graph this by hand, it looks different. You're introducing a variable in, so you should check your work. So let's go ahead and check this at the top here to make sure that works. So again, whenever you're multiplying by a letter, a variable, you should check. So let's make sure we get a true statement. So we're going to plug in x equals -2 into the x in the original problem. So we bring in the 1 minus 3 over 2 times the x that we got was -2. And we want to know, does it equal, so put a question mark above it, 7/4. Well, we got a negative times a negative. I know it's kind of hard to see because I have it going through the Q here. This was to say -2. But you got double negative, so negative times negative is a positive. And then you're left with 3 over, because -2 times -2 is positive 4. And let's bring down this 1 minus in front. So we got -3/4 we end up with. Does that equal 7/4? Now, depending on your professor, the professor we have in here, how do you pronounce your name, last name again? Salih. So if any of you have Professor Salih, this is a requirement that he would want you to see is checking your answer here. Now, again, depending on the professor you have, I know a lot of people are not fans of fractions. You can do this longhand, or if you are allowed to use the graphing calculator, it has a really nifty tool on it. If you look at the math button, you could type in 1 minus 3/4, hit the math button on your graphing calculator, choose the option 1, which will say frac. It brings it up to the main screen, enter, and it will actually reduce the fraction for you. Okay, so when we check it out here, we have 1 minus 3/4. So the double negative actually made this what I have a sign error here. Double negative, what should I have right here? What sign? Plus, because I had a negative times a negative, so there should be plus right here. So it should have 1 plus 3/4, and then when you have 1 plus 3/4, whether you're doing it on the graphing calculator or if you have to do it by hand, you would put 1 over 1, and then the common denominator is 4. 1 and 4 obviously both go into 4, so I'm going to multiply this by 4, but if I do it to the bottom, I got to do it to the top. So 1 over 1 becomes 4 over 4, so in other words, 1 is the same as 4 over 4 plus 3 over 4, and sure enough, that does equal 7/4. It is a true statement when you check it out. 4 plus 3 on the top for 7 over 4, 7/4 equals 7/4, so you get the same improper fraction back. So this does indeed work. All right, ready for question 13? Okay, find the domain. So domain is all of the set of all x coordinates that exist on the graph. So we need to be careful with the square root whenever you see any even root. With the square root, we're talking just about real numbers. So if you've dealt with those imaginary numbers with the little cursive I, those are not included when we talk about domain. So when we're talking about real numbers, there are some types of numbers that we cannot take the square root of. If you try punching it in your calculator, it's going to say error. What types of numbers can we never take the square root of? Negative numbers. Very good. We can take the square root of 0 because square root of 0 is 0. What times itself is 0 is 0. You can take the square root of any number. It might give you a hideous decimal of any positive number that is. We can take the square root of any positive number. Sometimes we get hideous decimals, but we can do it. But we cannot do negatives. So this is how we set it up every time with an even root. Is you look at the expression, the argument here underneath the square root symbol, 23 minus x, And I want to make sure that this is going to generate either a positive number then or 0, because those are what I can take the square root of. So how I write that in math is you're always going to start with the same symbol, greater than or equal to 0. Why? Because greater than 0 means it's positive, of course, or it can equal 0 exactly. So that's how you always start. Whenever it says domain and you have an even root, like a square root, always take the expression, and you're always going to write this greater than or equal to 0. That's the hardest part to remember. Once you remember that step, then you just solve for x. Now it's very similar to an equal sign, but the difference here with the inequality is that if at the very end I multiply or divide by a negative number, what do I have to do to this sign? Flip it around. So when we solve for x, first we subtract the 23. Now with an inequality, I'd recommend leaving your letter on the left because it's a little tricky to read otherwise. So we subtract the 23, so it cancels to 0, so we're left with negative x is greater than or equal to 0 minus 23, of course, is negative 23. Now remember, this is like saying negative 1x, so if it helps, you can put the 1 in here. I don't want negative 1x, I want positive x, so to undo the multiplication, I need to divide by the same sign, so that way it cancels the positive 1. However, warning here, I'm dividing by a negative number, so as soon as I divide by that negative number, I need to flip this sign around. So the greater than sign becomes a less than. Now if there's an equal sign like there is here, just bring it on down. So again, whenever you divide by a negative number, you flip your inequality sign around. And over here, negative divided by negative is positive. 23 over 1, of course, is 23. Now it depends on what professor as far as how far you want to take your answer. This is the correct answer, but a lot of professors want it in interval notation. So you're saying that what x coordinates exist on this graph are any x coordinates that are smaller than or equal to 23. So that means 23 is the biggest x coordinate possible. So it's going to go at the end of your interval since it's the biggest possible. Now solid equal sign, think solid bracket, because an equal sign means you want to include 23 in your answer. Whenever you want to include it as part of the answer, we use a bracket as opposed to an open parenthesis. And smaller than, that's a concept. Smaller than 23 means everything smaller than 23, smaller than is negative infinity. And any kind of infinity symbol, it's not an exact number to include in your answer, so it's always going to get an open parenthesis. So this would be your answer in interval notation. And again, interval notation, so you ask yourself when you get to the end, is this number the smallest or the biggest x can be? And when it's the biggest, like in this example, because all the x's are smaller than 23 or equal to it, so since it's the biggest, I put it on the right side. Now if I had ended up with a greater than sign, then 23 would be the smallest number it could be. Then in that situation, I would have started with a 23 and ended with a positive infinity, if that would have been the case. Yes, Professor Salih. Correct. The reversal of the sign is in the division step. So if you, for Professor Salih's students, how would you like them to write it? So this is if anybody has Professor Salih. This is his question that he's asking. We're going back to this step right here. And right. So as Professor Salih is pointing out, whenever you divide by a negative number, he's saying immediately flip this up here. Any other questions online? Okay. Express the radical in simplified form. So this would be from chapter 6 in your textbook. So remember, when you're dealing with numbers, it's a totally different ball game than when you're dealing with variables. So real quick, let's just recap on variables because I see this all the time. With variables, there's a property that we use here. So let's say we have the square root of, this is a separate problem altogether here. Just want to recall this little fact. If we take the square root of, let's say of x to the 100th power, it's totally different than if you're just doing the square root of 100. If you're doing the square root of 100, that's obviously 10. But with a letter, use this property. The variable, this exponent that's currently tagged onto it becomes the numerator, and then you divide by the root. And if it's a square root, obviously by the word square, that means you're dividing by 2. So the square root of x to the 100th is actually x to the 50th power. So if you have the square root of like y to the 16th, that would equal y to what? The 8th, because you divide by 2. So for square root, you divide by 2, and guess what you would divide by if that were a cube root? 3. And for a fourth root, divide by 4. So the problem that's going to come in is, obviously not everything is divisible by 2 if we're working with the square root. And when we want to simplify, we want to end up with integers. Integers meaning those non-decimal, they're no longer fractions. When we say integers, I'm talking about these types of numbers: -2, -1, 0, 1, 2. So all the non-decimals. So when we simplify a square root, we want to take as much out that's a non-decimal, that is an integer, as humanly possible. So when I have y to the 17th, we're going to have to break it up. So I'll show you what I mean. Let's go back to the original problem. So we're going to come back to that in a minute, that idea. Now the number, I'm going to go ahead and make a prime factor tree for. So 98, you can start with anything besides itself and 1 that goes into 98. I notice it's even. So 2 times 49, for example, gives me 98. Since 2 times 50 is 100, 2 times 49 must be 98, the even number below 100. And whenever I have a prime number, meaning divisible, of course, by itself and 1, I'm going to circle it, meaning that branch is done. 49 breaks down further into 7 and 7. So all my branches end with prime numbers. That's how I know I'm done with the factor tree. Now, as we're applying the square root to more and more things and more variables and numbers start popping out in front of this square root symbol, you see a negative there. That means it's like saying -1. So you're going to multiply it by the -1 that's already out there. So we have negative. I'm going to leave a lot of room here because stuff is going to start coming out in front. And we're going to replace 98 with its prime factors, which is 2 times 7 times 7. So when you do it this way with the prime factor tree, we look for it's a square root, we look for a matching pair of numbers. If we're a cubed root, we look for a matching triplet, or repeat 3 times. The fourth root, you look for a repeat 4 times. So with the square root, I look for a matching pair. So I have a repeat twice. And of course, we have a matching pair of what number? 7s. And for that matching pair of 7s, how many 7s will I put out front? Will I write out front? Just 1 per pair. Why? Because 7 times 7 is 49, and the square root of 49 gives 1 7 back. So for each matching pair for a square root, you kick out 1 of that number. So for this matching pair of 7s, I'm going to kick out 1 7. And I multiply it by the negative sign that's already was there in the original problem. Now let's worry about the letters. So out of these letters to begin with, we said if it's a square root, we divide the exponent by 2. Either of these letters, can we apply the square root to then right away? Can we divide either of their exponents by 2 right away and kick them out front? The Q, very good. So the Q, since it has that 8 there, 8 is divisible by 2, the root 2. So that becomes Q to the 4th when I divide by 2. So as soon as I apply the square root, I kick it out front, and it's times that negative sign that was out front, -1. So I have 7, -7. So q to the 4th came out because the square root of q to the 8th is q to the 4th. And now here's the tricky part, the k to the 7th. If you try taking 7 divided by 2, we get a non-integer. We get a decimal out. We don't want any decimals here. So 7 divided by 2, since it's a decimal, what we want to do is say, okay, well, at least some of those k's I can apply the square root to. So we ask ourselves, what's the biggest number closest to 7 without going past 7 that is divisible by 2? 6. Good. So I'm going to write k to the 6 times, if I take away 6 of those k's, just simply subtract 6 from the original exponent you had, how many k's am I left with? 1. So k to the first, which is just simply k. So, and you can see this works. We're used to going backwards. We're used to saying k to the 6 times k, that's k to the 7th. We're going backwards. And now, why did I do that? Because I can take the square root of k to the 6 at least. So k to the 6, the square root, just simply divide the exponent by 2, and we get k to the 3rd power. So when it's all said and done, now it's multiplication, so the order doesn't matter, but I'll go alphabetical. So 7, negative 7. I'm going to put my k cubed first, then my q to the 4th, square root of, and let's see what we're left with. We're left with the 2, and we're also left with the k. Oh, the order. Somebody is asking why doesn't q go first? The order does not matter. It's a really good question. I could have left the q to the 4th first and then put the k to the 3rd because it's multiplication. It's like saying 2 times 3 times 1 is the same as 1 times 2 times 3. The order I multiply in does not matter. So you could, if you left that q to the 4th before the k cubed, you're perfectly correct. It's just a lot of times proper notation. A lot of times on a multiple choice test we'll go alphabetically when we have letters. Variables. So sure, you could put negative 7, q to the 4th, k cubed. I could have left it like that. Good question. Any other questions? Okay, question 15. So again, we want to solve. So notice that x is trapped under a square root. So eventually we're going to have to find a way to undo that square root, to unleash that x so we can actually solve for it. So first get the square root symbol there by itself. So if I want to get the square root by itself, let's add over the 7. So remember, adding, we just do once to each side. So square root by itself first when x is trapped underneath it. So the square root of 6x minus 10 equals, we got 0 plus 7 for 7. Now, how do we undo a square root so I can get in there and solve for x? We square it. Very good. Squaring will always undo a square root. If you had a cube root, you would take it to the 3rd power to undo it. If you had a 4th root, you take it to the 4th power to undo it. You get the gist. But if I square one side, I better square the other side. It has to be in balance. Picture a balance instead of scales there on top of that equal sign. What does that do? It actually undoes the square. Pretty cool. So square gets rid of the square root on the left side. So we are left with 6x minus 10. Yay! So now the x is out, so we can actually solve for it. And now we square the 7 on the right side to give us 49. So 7 squared for 49. Now it's much easier to solve for. You'd solve for just like normal. Let's add the 10 over to the other side. So we have 6x equals 49 plus 10 for 59, of course. Divide over your 6. We get an answer of 59 over 6 for x. And we can check that, just like we checked a couple slides ago, to make sure it's a true statement. Yeah. Why can't you do what? Oh, you cannot combine the 7. Whatever's outside of, think of whatever's underneath the square root is underneath the safety zone. It's untouchable until that square root is gone. So the 10 and 7 are not like terms anymore because one is trapped under a square root sign and one is not. So the one that's trapped under the square root sign is stuck under the square root sign, if that makes sense, until we get rid of the square root sign by squaring it. Very good question, yeah. So those numbers, I know usually if there is no square root sign there, sure, you take negative 10 minus 7, you get negative 17. But because we're not applying that square root does not extend over top of the minus 7. So that minus 7 is not part of what's underneath the square root. So I'm not allowed to combine them if one is under square root and one's not. Sure. Excellent question. Sure. The question was, when you have a square root, when do you use the plus or minus symbol? Whenever you're solving an equation and you're putting in a square root to get rid of a square, so if it were the reverse, like if I had this, here we just have one answer, just the positive. But if I had x squared equals 16 and the directions were solve, whenever I put a square root in there to get rid of the square, that is when I need the plus or minus symbol. And square root undoes a square just like the square undoes the square root. And that you need the plus or minus on the opposite side of what you just canceled out. So x equals, on my homemade example here, x squared equals 16 was my homemade example here, plus or minus square root of 16 is 4. So yeah, when you have a square and you yourself put in the square root to solve, that's when you need both answers to account for the plus or minus. Excellent, excellent question. Yes, Professor Sully. Professor Sully is pointing out that we are going to check it. Okay, so just to we do need to check to make sure, because sometimes, especially with these root problems, the answers don't always work. You do have a few oddballs, problems you might have noticed in your homework exercises where it doesn't work out. So you do need to check the answer. So that means you just simply plug in our answer for x back into the original and make sure it's a true statement. So we had the square root of 6 times our x was 59 over 6 is what we're saying should be the answer, but we're checking, minus 10, and then outside of the root is minus 7, and we want to know, does that equal 0? Okay, let's put the 6 over 1 so we can see it better. So these 6's, since we're multiplying, they're on the diagonal, canceled to 1's. So we're left with 59 minus 10 under the square root, minus 7 outside of the root. Does that equal 0? So that's the square root of 59 minus 10 for 49, minus 7. Does it equal 0? It sure does, because remember, the square root that's already in the problem, we only look at the positive answer, so that's positive 7 minus 7. That certainly does equal 0. This is a true statement, so that tells us that this answer does work. So you do need to check that with square roots. So since we have 0 equals 0, because 7 by 7 of course is 0 equals 0, we got a true statement. That answer works. Any other questions? What's that? Oh, yay! I like smiling faces. And I like saying yay, sorry. Okay, solve by factoring. So the first one, the first trinomial is nice because check out the leading coefficient. It is a 1. Yay. When we get to the one with the k's, not so nice because we're going to be stuck with a leading coefficient other than 1, so we're going to have to implement a method. So when the leading coefficient is 1, we can just think it out logically. Now, if you, like we said before when we were doing this, if you want to use a method, you can. It will work, but you don't have to. It'll make it a lot slower. It would slow it down a lot. All right, so I'm going to bring down the equals 0. So our first visible sign that we use is a plus to bring down, and then you multiply the two signs together. A positive times a negative is a negative. 1x squared, well, the only multiples that give you 1x squared are x and x. And unfortunately, we got to think of multiples of 80, but it's not too bad. That when you add and subtract, remember we said our goal with the trinomials is always that middle term. So if I want positive 2, think of all your multiples of 80. When you add and subtract, that will give you 80. So they got to be pretty close together to add and subtract to give you 2. And so we get what multiples? Very good. 10 times 8. And again, it matters what goes with the plus or minus. If I want a positive 2 coefficient, I'm going to add that 10 and subtract the 8. And you could check this by foiling it out. And now, we're not done yet, because it says solve. So we need to set each factor equal to 0. The first thing being multiplied, your first factor is x plus 10 equals 0. Your second factor being multiplied, x minus 8 equals 0. So of course you get opposite signs here, because to get x by itself here, we're going to subtract the 10 to the other side. So we get x equals negative 10. 0 minus 10, of course, negative 10. So there's our first answer. Over here, we're going to add the 8. So x equals 0 plus 8 for 8. So our answer is negative 10 and 8. Negative 10 and 8. Questions on the first one before we move on? Okay, we'll come back to this big bad trinomial where we have to use a method because there's lots of choices there. Let's move down to the bottom one first. So we always, I should emphasize this, when you're factoring, you should always, no matter what type of factoring, always check for a GCF other than 1. Does something besides 1 divide into all the terms? And until now, we either used GCF method, or for our trinomials, the GCF has always been 1. Here, that's not the case. So here we got 2 factoring methods in one problem, because both 4k squared and that 64 are divisible by 4. So first we see that we have a GCF of 4. 4 goes into both of them, divides into both terms, and it's the biggest number to divide into both terms. So remember, we use the GCF twice. We're going to divide by 4, and then to get our new terms, so we put the 4 out front, and then to get the new terms is when we divide by the 4. New terms in the parentheses, that is. So 4 over 4 goes to 1k squared minus 64 divided by 4. So we get 16. And then we just bring on down the equals 0. So GCF method of factoring first. And now we see we can go even further, because what type of factoring do we have in the parentheses now? Difference of perfect squares. How do I know to implement that method? Well, there's always exactly 2 terms, 1 minus sign, and I can take the square root of each term and get an integer out, meaning I can get a non-decimal out. So I bring down the 4, and then I can forget about it here. Bring it down. And now I'm going to put 2 blank parentheses together, equals 0. Now remember, once I've identified its difference of perfect squares, the minus sign means opposite in math, so you're always going to have opposite signs in your answer. To get the terms in the first spot, you take the square root of the first term. Since it's the difference of perfect squares, square root, think. So the square root of k squared, in other words, what times itself gives you k squared? Is k. Or you can do like we did on the other slide and take 2 divided by the root 2, so to the first power, k to the first power. And then we take the square root of the 16. Don't worry with the minus sign. We already took care of the signs. So the square root of 16, what times itself is 16? Is 4. Goes into these spots. This here is 4, and this here is k. So k, square root of the first term goes in the first spots, square root of the last term goes into the last spots. Now, we set each factor again equal to 0. However, there's a little bit of an issue, right? Because what's the very first thing being multiplied? It's not even in parentheses. It's a 4. If I write 4 equals 0, that doesn't even make any sense. It's not true. It's a false statement. So the reason we're allowed to ignore the 4 mathematically is we can argue I can divide that 4 over to the other side because it's not of no variable that I'm eliminating here. So I don't count the 4. Now if there was a k attached to that 4, then I would look at it because there's a variable. but since it's just 4 by itself, 4 equals 0 is a false statement. 4, we discard it. Now let's look at the other factors. K plus 4 equals 0. And then the last factor, K minus 4 equals 0. So we subtract the 4 over. So we have K equals 0 minus 4 for negative 4. There's an answer. And then we add this 4 over. So we have K equals positive 4. So negative 4 and positive 4 would be our two answers on this one. The factor 4 goes away because you can look at it two different ways. Since there's no K with the 4, it's just a number by itself. When I said each thing being multiplied, when I say each factor, I mean each thing being multiplied equal to 0, the first thing I said equal to 0 was that 4. When I say 4 equals 0, that doesn't even make any sense. It's a false statement. There's no letter to solve for. It's a false statement. So if it's just a number by itself, we can ignore it. Or you can look at it mathematically like this. Because it's just a number, you couldn't do this with a letter at the end. I could divide the 4 over to the other side. Because 0 divided by 4, we can have 0 on the top, just not on the bottom of a fraction, is 0. Remember, it's, now this is cheesy, but I always say it's okay to have 0 on the top. It gives you 0. Think okay and no. But we can never have 0 on the bottom. That's undefined. Zero on the bottom trumps anything. So think okay to have 0 on the top, that's 0, no, it's undefined. So if you had 0 over 0, the 0 on the bottom wins out. That no wins over okay. That's undefined. I'm running around a room. It's a very good point. Good question. Any other questions out there? Now, does everybody have these answers? I'm going to erase it because this last trinomial is a biggie since the leading coefficient is not 1. Okay, it's going to vanish. All right. So are we AC method people, Colombian method people, or trial and error people? So if you could answer through, is it raise your hand? Or type it in rather. If you could type in, do you use AC method? That's when, if you're going, I'm not sure what to use. AC method is when you take the first and last terms, multiply them together, and you replace the middle term with two terms, and you end up doing grouping every single time. Any Colombian method people? Would you like to see it done, Professor Alfaro, just AC method way or both ways? So both ways? Okay, so let's start with AC method. We're going to do AC method first, and then we'll do the Colombian method. All right, so first doing AC method way, our A, make sure it's in descending order with the biggest degree, remember degree in an algebra class meaning exponent, first. So K squared, then your K to the first, then your number without a letter, and it is. Your A is your leading coefficient, the one right in front, in this case in front of the letter squared. So that's 2 times your C is negative 4. Equals negative 8 is your AC number. Now you can either see from here, because you got a negative number, that you're going to use one of each sign, or you can make a note. Remember, you always use the first visible sign, which is a minus. So what I like to do is I like to write it kind of above here to remind myself so I don't forget. And then you multiply the two visible signs together. Minus times minus, of course, is a plus. So even if, say, worst case scenario, you forgot about this negative sign, let's say you accidentally just wrote 8. That way, if you make it a point to write your signs over here, you won't forget, okay, I need to use one of each sign. And again, the goal, of course, is the middle term. So if I want that middle coefficient of negative 7, thinking of multiples of 8, we have 8 times 1 or 2 times 4. If I want to add and subtract, the multiples that will give me negative 7 are going to be 8 and 1. If I want negative 7 you have to subtract the 8 and you have to add the 1. So these are going to be my new coefficients of my two new middle terms that will replace the negative 7k. The order most of the time does not matter, so I'm going to plunk these down in just the order I happen to write them. So I bring down the first term, 2k squared. Now instead of negative 7k, I'm going to write the multiples we chose, negative 8. Don't forget the ending is k. And then we have plus 1k, which is the same as plus k. And I bring down my last number, minus 4 equals 0. And you can see we didn't change anything from the original problem. We're allowed to do this. Negative 8k plus 1k, sure enough, that's negative 7k. Now that I have 4 terms, I can try grouping. So I'm just separating them with a little dotted vertical line. So the GCF originally was 1. That's 1 goes into all 3 terms and nothing bigger. But now that we do grouping, if I look at just the first pair, there's something besides 1. There's a term besides 1 that goes into 2k squared and 8k. For starters, number-wise, 2, of course, goes into 2 and 8. And they both have the same letter, so the GCF is the smaller powered one, so that's k to the first, or k. So 2k goes into both terms. And now we take each of those 2 terms, and we divide by the GCF as well, just like we have been doing. So the 2's cancel to 1, so you're left with k squared over k for k, minus your k over k cancels to 1, so you're left with 8 divided by 2 for 4. So we list the GCF out front, and then I divided each of these 2 terms by 2k to get the new terms k minus 4 here. Now, easiest part to forget, what do I always do with the second to last sign? Always bring it on down. So it's a plus sign, and you're going to include it as part of your GCF of what you divide by. And now the last 2 terms have nothing in common, so what divides into anything? What number divides into anything at all? 1. So I do need that 1 as a placeholder, because when you have 4 terms, you're doing grouping, you need a binomial times a binomial as your final answer. So I do need to write 1 as a placeholder there. And now we divide those 2 terms, k minus 4, by positive 1, which will just generate the same terms back again. Now, why I'm emphasizing this is I see mistakes when there's a minus here a lot of times. If this were a minus that I had brought down, then I would have needed to divide by negative 1. So point being, you need to divide by the sign with the GCF. So when I divide both of them by positive 1, you get k minus 4 back again, equals 0. Now we're going to know if we're on the right track because we should have the exact match in parentheses, same signs and everything, and we do. So we get match times leftover. So our match, clearly in these 2 globs of terms here, separated by our plus sign in this instance, our 2 match, our GCF, as math speak would go, of these would be k minus 4. Our match is k minus 4. And when you divide out the k minus 4 from each of these 2 globs, the leftover stuff from left to right, well, in front, the leftover stuff, when you take away, when I say take away, I mean put out front, the k minus 4 is 2k. And the leftover stuff in front here, plus 1. So match times leftover for grouping, and just bring on down the equals 0. So here is how you get the answer with the AC method. Now it's factored. Now we do as before, set each factor equal to 0. So k minus 4 equals 0. 2k plus 1 equals 0. And you solve each for k. So we're going to add the 4 on over. So k equals 0 plus 4 for 4. Over here we subtract 1. So 2k equals negative 1, and we divide over the 2, and we get negative 1/2. So 4 and negative 1/2 are our 2 answers here. Questions on AC method before I'm going to go to a white screen in a second and redo this with Colombian method, so you can see what you guys like better. Okay, so I'm going to write this two different ways because it depends on which professor you have. If you received a handout, there's one way of writing it. If you have Professor Sully, to have an equivalent way, there's another way of writing it. Either way, it'll give you the right answer. So we have 2, let me write down the original again here, k squared minus 7k minus 4 equals 0. Okay, so 2 ways of going about this. All right, so if you learned it the Colombian way, you were taught that you start always with this leading coefficient. You take this a, which is 2, and you times it by itself, and you times it by the last number is the first step. When you do that, 2 times itself gives you 4k squared minus 7k minus 4 times 2, which is 8, equals 0. Or, like Professor Slee pointed out, technically that's not equivalent. So technically, mathematically, the equivalent way would be to multiply everything by 2 because it's not balanced if you don't multiply the middle by 2. So the other way you could write this that would be mathematically correct would be multiply everything by 2, so that would be 4k squared. When you multiply the negative 7 by 2, you get negative 14k minus 8 equals 0, but then you also have to put this whole thing by 2, because if you're multiplying one side by 2, you have to divide by 2. Okay, so if anybody has Professor Sully, this is his preference. All right, so now we get our parentheses ready. We write equals 0, so this is most likely the way that you were taught it. Doing it this way, you take the square root of the first term, always goes in the first spots. So the square root of 4k squared, in other words, what times itself gives you 4k squared is 2k. Now you might notice a pattern here. For me, when I do the Colombian method, when I teach it in class, I just skip. I go right from this step down to here, and I just make a little mental note that your AC number, I just take the A times the C, 2 times the negative 4 gives you negative 8. Why? Because notice the pattern here, guys. You're always going to end up with the same number back again. You just end up dividing the exponent by 2. So if it's 2k squared, you end up with 2k in the first spots. What if I had a 3k squared? What would end up in the first spots? 3k. What if I had a 4k squared? What would end up in the first spots? 4k. So why do they show you this step? Because what if you had a k to the 4th? If you had a k to the 4th, you end up dividing it by 2. That's why they show you the square root step. So if this were 2k to the 4th, you'd end up with 2k squared. So you end up with the same number back again and dividing the exponent by 2 essentially. And then you drop down the first visible sign, which is a minus, again as usual. Minus times minus is plus. And now here's the tricky part. Our AC number. So whether you write it like this is what you're used to, or off to the side, either way it's an 8. And we're adding and we're subtracting, and so I want multiples of 8. As usual, the goal is the middle term. So if I want a negative 7 and I'm adding and subtracting, what multiples of 8 am I going to use? 8 and 1. Good. 8 times 1. And we have to subtract, to get that negative 7, we must subtract the 8, and we must add the 1 to get that negative 7. Now be careful with the Colombian method, because we're used to it with trial and error and AC method, bam, we're done here. You always have to check, can you simplify this further? And you can. You're going to notice you're going to end up with the multiples that give you this 2 originally, this leading coefficient is A, because 2k and 8 are both divisible by 2. So I have that fraction bar, meaning you're going to divide both terms by 2. Here, these last two terms have nothing in common, so they're always divisible by 1. So it's kind of just a fun little note to the side that 2 times 1 does give you 2 back again. But just simply remember, you're going to simplify where you can. So when I divide each of these by 2, 2k divided by 2 gives me 1k, or k. Negative 8 divided by 2 gives me negative 4. And so 2k plus 1, there's no way to simplify it, that's why I have it over 1. You just end up with 2k plus 1 back again. And if you check, if you wrote down the AC method way, you end up with the same exact factors as with the AC method. And then you would just solve it like you normally would, where you set each factor equal to 0. We already did that. We already know the answers are 4 and negative 1/2. So that step we already did with the AC method. Set each factor equal to 0, and you'll end up with 4 and negative 1/2. Now, going about it this way, so you're showing that this 4k squared is a perfect square of 2k. If you're doing it with Professor Salih's way of the Colombian method here. And you have your minus 8 equals 0. And since he multiplied everything on the left side by 2, you got to divide by 2 to keep it balanced. That way it's like multiplying by 1. And now in parentheses, and the whole thing is still over 2, of course. You put this first term that's being squared, in other words, just like we took the square root in the first spot. Bring down the first visible sign. Negative times negative is positive. And the same as before. Professor Sully, do you still look for multiples that give you 7 from the 8? Okay, so the same way if you have Professor Sully. So you want multiples that give you 8 when you add and subtract, which we already said are 8 and 1. They give you that 7 was the original middle term. So you're going to subtract the 8 and add the 1 still. And you see you end up with the same thing as we have over here. Alright, so it depends on which professor you have. Most likely you were taught the way on the left. Professor Salih is pointing out mathematically wise, if you want equivalency, he would prefer it to be written like on the right. Questions on Colombian method? Are we still AC method fans? Are we still awake and alive? Okay, drink some caffeine. Alright, next slide, 19. So we're going to use the square root property to solve. So first let's so this brings us back to that excellent question somebody asked about when do you bring in that plus or minus. We're going to see that here. So first, before we solve for z, let's get z squared by itself. So to get z squared by itself, we're going to add over the 448, that is, ones to each side, so that goes to 0. So 7z squared equals 0 plus 448 for 448. We divide over the 7 now. And that surprisingly is going to divide out nicely. If you're allowed to use a calculator, you can just punch it right in, of course. Or if you do it longhand, you see that you end up with 64 when you divide by 7. Now, to get rid of, or to undo a square, we said before, the square root. Yeah, the other problem, we had the square root that we undid with the square. So now we're using the square root. So here is when we use the square root, when we're putting in the square root, we said that wasn't already there. That's when we need what on the opposite side? The easiest part to forget? Plus or minus. Yeah, so when you see solve, and you yourself are putting in a square to undo a square, you're putting in a square root, excuse me, you're putting in a square root to undo a square, that's when you use the plus or minus. So z equals, bring down your plus or minus, square root of 64, of course, is 8. That comes out nicely. Nice integer, non-decimal answer. So we have two answers, plus or minus 8. Right, or you could think of it like this, because the square root is like to the 1/2 power.
Hey, if you're listening online, we just want to specify that when you take the square root of a variable such as z, technically z has some negative and some positive numbers in its domain. So we should write the absolute value of z when we take the square root of both sides in this case. The answer still turns out to be z equals plus or minus 8.
Thank you. Any questions on this, guys? Okay, question 20. So solve the problem using Galileo's formula, d equals 16 times t squared, where d represents the distance above ground and t is the time. So it says Eric has a treehouse 26 feet above the ground. How long would it take a water balloon dropped from the treehouse to fall to the ground? All right, so we're given, for these type of formulas, we're typically given one of the variables and we have to solve for the other. So we're given the distance here. We're given, you can look at the units even, feet for distance. And how do I also know that I'm given the distance because it's asking me to solve for the opposite variable in the formula, t for time, because it says how long would it take. So that means I must have to find t, I have to solve for t, and they must have given me d. So our distance from the ground, they tell us it's 26 feet. And so I'm going to plug that into the formula. So 26 goes in for d. I bring down my equal sign. 16 t squared. Now first let's get, just like in the last problem, we got z squared by itself first. We're going to get t squared by itself first, and then we'll solve for t. So divided by 16. So we can reduce 26 over 16. Because they're both even numbers, are divisible by 2. So 26, when I divide the top and bottom by 2, becomes the equivalent fraction 13/8 equals t squared. And just like in the last problem, how do we undo a square? Square root. Or you can look at it as the correct way would be you end up, when you take a square root, you end up with the absolute value of that opposite side. But as Professor Alfaro pointed out, in your classrooms, you don't always see the absolute value. So when you take the square root of each side and it gets rid of that square, don't forget you have two answers. Yet again, we're putting in a square root when there was a square, as mentioned before, plus or minus. Now, in this case, we've got to look at the context of the problem. And it is time. So they want the decimal format. And it doesn't make any sense to have a negative time. So even though we usually put plus or minus, it doesn't make sense to say it took negative so many seconds for that water balloon to hit the ground. So in this case, we're not going to look at the negative. We're just going to look at the positive. So if you type this into your calculator, so this is from a review packet actually that is in the Math Depot that you can scoop up if you want to swing by. But they do want it in decimal form, so if you take the square root of 13 over 8, when you type that in your calculator, make sure you close the parentheses after the 8, you get 1.3, and if you look here, it tells us that the time, I believe it's seconds. T is the time, has a treehouse. Doesn't say it in here. I think if you look at the full problem in the Math Depot, it is in seconds, I want to say. So I'm going to put seconds in here. So 1.3. When you plug that again, all I did was plug that in the calculator. If you're going, oh, what'd you do with the square root of 13 over 8? So that's a nice one where you actually plug into the calculator. Okay, any questions on this one? 21. Use the quadratic formula to solve the equation. Now, you could use the fractions and plug them in, or a lot of people don't like to use the fractions, so if you wanted to, what we could do is that old trick from way back around question 10, which is multiply everything by the LCD, and we don't have to worry about using the fractions. So, what's the smallest number that 3, 2, and 6, when I analyze the denominators, all divide into? 6. So what we can do is let's multiply every single one of those fractions by 6 over 1. And that way it gets rid of the denominator so we don't have any fractions left. So z squared over 3 times 6 over 1 equals z over 2 times 6 over 1 plus 5 over 6 times 6 over 1. So notice I multiply every single term by the LCD over 1. And again, you could multiply across, like here I could get 6z squared over 3 times 1, 3, which gives you 2z squared when you divide it out, or you can do that fun since we're multiplying slashing because 3 and 6 are both divisible by 3. So the 3 goes to 1, 6 divided by 3 goes to 2. So we have 2 times z squared for 2z squared. Since it's over 1, I don't need to write the over 1. Equals 2 goes into 6 3 times, so 2 divided by itself is 1. 6 divided by 2 is 3. 3 times z for 3z over 1 times 1 are 1. Or if you multiply it across, 6z over 2, which goes down to 3z if you don't want to slash. Plus, on the diagonals, we have a matching 6 divided by itself. Those become 1s. 5 times 1 is 5. And again, you don't need to write over 1 because that is still just 5. Now, before we can solve with, they want us to use quadratic formula or factoring even, we always have to have it set equal to 0. It's going to make it easier if we're using quadratic formula or factoring for that matter if we have a positive leading coefficient. So I'm going to move all my terms to the left side. That way the number in front of the letter squared, the variable squared, is positive. So I'm going to subtract 3z to move that to the left side, and I'm going to subtract 5. So in descending order, we have 2z squared minus 3z minus 5 equals, since I moved everything away from the right side, we're left with 0. So now we're allowed to use quadratic formula. Now this does factor, but if it specifies a method, then your teacher wants you to use that method. So we need to use the quadratic formula here. So the a is going to be 2 in the quadratic formula. Our b is going to be negative 3. And our c, don't forget the sign in front, it's not just 5, but it is negative 5. Now I'm going to go to a different slide in a second. I just want to give everybody time to make sure that we're all on the same page here. Everybody's all caught up. We're good to go, Hector? Okay, so let's go to the new slide. So we already said that a was 2. Let me recopy that down. B was negative 3, and Z was negative 5. And we're solving for the letter Z. We're saying X equals, so Z equals. Remember, quadratic formula is negative B plus or minus the square root of B squared minus 4AC, this whole right side, divided by 2 times A. So that's the formula we're plugging into. So that equals, so we bring over the negative from the formula. B was negative 3 plus or minus square root b squared. Now be careful here because b is not just 3, it's negative 3. So I want to square not just the 3, I want to square the negative as well. So whenever you're plugging in a negative number, you need to put parentheses around it. So it should look like this, or else you're going to get a sign error mistake. So b negative 3, negative sign included, is being squared, minus 4 times a was 2 times c. My c is negative 5. And that whole thing is divided by 2 times my a is 2. So first, well, we can look at here. Double negative, there's no exponent. We can assume it's just to the first. So double negative, this means take the opposite sign of negative 3. So this becomes positive 3. Plus or minus. And let's work on that, what's underneath that square root. So negative 3 times itself for 9. When I do the minus 4ac part, I always do the sign first and then I do the number. So we have a negative times a positive, which is a negative, times another negative for a positive. And now that I took care of the signs, I can ignore them and just concentrate on the numbers. 4 times 2 for 8, times 5 for 40. Whole thing divided by 2 times 2, 4, obviously. So we have 3 plus or minus. So keep chipping away till we get one number under that square root, and then we'll see if we can simplify the square root. We got 40 plus 9, so 49 under the square root, all divided by 4. Now this works out nicely, because square root of 49, I can apply the square root to the 49. Square root of 49 is 7. So we have 3 plus or minus 7 all over 4. So this plus or minus, since we're adding and subtracting a number other than 0, represents how many answers here? 2. Good, good, good. So the first one, let's concentrate on the plus first. So the first one is 3 plus 7 over 4. So that's 10 over 4, but we have to ask ourselves, can we reduce? And we can, because something other than 1 goes into the numerator and denominator. 2. So I divide the top and bottom by 2, and I get my first answer, the improper fraction of 5/2. And now we're going to look at the negative situation. So 3 minus 7 over 4 gives me negative 4 over 4. Negative divided by positive, negative. 4 divided by itself, 1. So we got negative 1 and 5/2. Okay, 22. We're almost there. 25 total. Find the vertex of the parabola. So we need to memorize the formula for the x-coordinate. Once we have the x-coordinate, we can figure out what the y-coordinate is. Because remember, f of x means the same as y. The only reason sometimes textbooks use that notation is that's function notation. It's a way of saying, hey, this is not just any equation, this is a function. So remember, f of x, any letter of x, that's the y-coordinate, that's your output. So the vertex, the x-coordinate of the vertex of any parabola is negative b over 2a. And what is nice is your ABC is the same as it was with quadratic formula. So your a here, number times the letter squared, your leading coefficient is 3. And your b, sign included with the in front of the x, is positive 18. So that's negative, b is 18, all over 2 times a was 3. So we have negative 18 over 2 times 3 for 6. So we have negative 18 over 6. So our x-coordinate of the parabola, of the vertex of the parabola, is negative 3. And remember, vertex means simply where that parabola opens up, that U-shape opens up. So the x-coordinate is negative 3. Whenever you have an equation and you have an x, you can always get the y by just plugging in. So if you'd rather write that as y, you can. So you have y, your y coordinate equals 3 times, I have x, it's negative 3. So I plug it into each of these x's I see here. So negative 3, and it's going to be squared, plus 18 times negative 3 goes into this x as well, of course. And then we have plus 25 that I bring down from the original formula. Now, if you wanted to keep your function notation, note that you would write it like this. You might have seen it probably as this in class. F of, and the x-coordinate was negative 3. That's your input. Whenever you have a number inside this function notation, inside the parentheses, that means they're giving you x, or we just found x, and we need to find y. So we're finding f of negative 3, the y value when x is negative 3, in other words. And now we just solve it down. There's not more than one number in parentheses, so we go into exponents. Negative 3, notice you're squaring the negative as well as the 3, so negative 3 times negative 3 gives you positive 9. And I bring all the rest down. Now we go on to the multiplication and division step, order of operations. So we get 27. Positive times a negative is negative. 18 times 3 for 54. When you multiply that out, bring down the plus 25. 27 minus 54 gives me negative 27 plus 25. And we have our y value, negative 27 plus 25 of negative 2. So let's go ahead and write this as a point. So our x-coordinate was negative 3, and the y-coordinate, when you plug in the x, was negative 2. And again, this formula just unfortunately just needs to be memorized. For x is negative b over 2a of vertex. Question 23 says, solve the problem. John owns a hot dog stand. His profit in dollars is given by the function p of x equals negative x squared plus 10x plus 33, where x is the number of hot dogs sold. What is the most he can earn? So we want to know his maximum profit. So whenever you're talking about most or least, or you see maximum or minimum in a word problem, where the biggest exponent or degree we would say is 2, we're talking about a parabola. And if we think about this shape, whenever you have a negative in front of your x squared, that means your U-shape, your parabola, is going to open up or down if it's a negative. Opens down. Good. So the maximum value, the most he can earn, if I'm looking at this visually speaking, is going to be at the top here. So my maximum, when I get this hill shape, because it's an upside down U, thanks to that negative leading coefficient, is going to be at the vertex of the parabola. Now let's see. So we just need to determine if we need to find x or if we have to find y. So x is the number of hot dogs sold. That's not what they're asking for. They're not asking for the greatest number of hot dogs sold. They're asking for what's the most he can earn. They're asking for his profit, p of x, which is the same as y, keep in mind. So in other words, when we translate what this word problem really means is I want the y-coordinate of the vertex. Will give me the answer here. Now if they said, what is the greatest number of hot dogs he would have sold, that would be the x-coordinate of the vertex, as specified here in the problem. So unfortunately, we got to find x first, and then that way we can plug that number in to get y. So same as problem as before. So if x, remember the formula, negative b over 2a. So that's negative, our b this time is 10. All over 2 times a. If it's just a negative sign in front of x squared, what number can we assume is there? What coefficient? Negative 1, we can assume. So a is negative 1 if it's just negative x squared, so negative 1. So we have negative 10 divided by negative 2. We multiply that out. Negative over negative, positive. 10 divided by 2, of course, is 5. So we got the x-coordinate. So that's the most number of hot dogs sold. But we want to plug that in to get our y-coordinate for our profit. So you can either write it as y equals, or you could write p of our x we just found is 5. So either way, you're finding the y-coordinate when x is 5, however way you want to look at it. And we plug it into the original. So there's that negative sign. Kind of hard to see because I put that 1 in there, but there was a negative in the original problem. And then you're squaring x after the negative, after you bring down the negative. So your x you just found out was 5. So I'm just squaring 5. So this time I'm not going to put my negative in parentheses because I'm only squaring x, and x was a positive 5. So you just got to bring down that negative sign because the negative sign was part of the original equation. X did not equal negative 5 that I'm putting into it. Plus 10 times, instead of x again, I write 5, plus 33. And not having those parentheses changes up the sign because I'm only squaring the 5. So when I square just the 5, 5 times 5 is 25. Since there's no parentheses, what do I do with this negative sign then? Bring it on down. Now parentheses, you bring it down. So even though 5 squared is positive 25, when you bring the negative down, you end up with negative 25. 5 times 10 for positive 50. Bring down the plus 33. So we have negative 25 plus 50 for 25 plus 33. So we get 58. And now this is a word problem, so we need units on it. We're talking about profit, we're talking about money, so let's go and put that dollar symbol in. So his maximum profit is $58. So as soon as you can visualize the shape and you see that it's really the vertex they're asking you about, it's not that bad of a question. Questions on that? Everybody see why we left the negative alone in this one? Because we were bringing it down from the original problem. And we plugged in a positive 5 for x.